I want to talk for a few minutes about what algebra is. When I first studied algebra myself, I didn't understand the basic concept of algebra, and this made learning it very confusing for me at first. So I'm hoping I can help you avoid that. Let's start out with an example. Imagine that you're at the store stocking up on tomato sauce. You're going to buy several cans of the same kind of tomato sauce. Without using any numbers, I want you to tell me how you would calculate how much you'll owe at the cash register. In other words, what will your total cost be for all these cans of tomato sauce? Think about that for a minute and pause the video until you have your answer. See if this is what you came up with. To figure this out, I would take the number of cans you're buying times the price per can to get the total cost. This is what it looks like written as an equation. What's important about this equation is that you notice it works no matter how many cans of tomato sauce you buy, and no matter what the price is for each can. Whatever number of cans you buy and whatever the price per can is, this equation will still work to find the total cost. This is one of the important ideas about algebra. It allows you to write down the pattern of a calculation without using any numbers. This pattern says what calculation you would do every time in a particular situation, no matter what the numbers were. Once you've written down this pattern, you can use it to calculate your cost once you do know the numbers. When you decide how many cans of tomato sauce to buy, and you know how much each can costs, you can use this equation to calculate your total cost. We wrote this equation for cans of tomato sauce, but the same pattern would apply if you were buying motor oil or loaves of bread. It didn't matter that you were buying cans of tomato sauce. As long as you're buying a bunch of the same item, the same pattern works. So we can take the equation, the pattern that we wrote, and write it even more generally. Instead of specifically saying cans, we can say so we have our pattern, which we wrote in the form of an equation. Next, we need to write it the way mathematicians would write it. Depending on your point of view, mathematicians are either lazy or we are efficient. We like to write things down quickly and say what we want to say with a minimum of writing. It's kind of like texting. We're going to write this more efficiently, and the first way we're going to do that is to replace phrases like number of items with single letters. We can pick any letter we want, but we usually use small letters, and many times we'll pick a letter that's related to the phrase so that it's easy to remember. Now we're ready to write our pattern, our equation, in slightly more compact form. Once we replace the phrases with letters, the equation at the top of the screen becomes the equation at the bottom. There's one problem here, though. We've used small letters to stand in for our phrases in the equation, but we're also using the small x to mean multiplication, and this could be confusing. To avoid this confusion, we're going to use what we call a different notation. There's a separate lesson on notation that you might want to take a look at, but for now I'll just tell you that notation means the way we write something. In this case, mathematicians have decided that to show multiplication in algebra, we'll just get rid of the x and write the n right next to the p. In algebra, whenever you see two letters right next to each other with no other symbol in between, it means that these two things are being multiplied. Remember that in this case the NP means number of items times price per item. In part 2 of this introduction to the concept of algebra, I'll come at this same idea from a slightly different direction, and I'll show you a little bit about where algebra is used in the world around you.